Cool, let's get started. Okay, so we're gonna go and switch over to my fun title. Hey everybody, thanks so much for taking the time to be here today. I super appreciate it. I know there's a bunch of other talks that you guys can be to, but you guys picked mine, so thank you. We're gonna talk a little bit about how IT at the Gates Foundation has been able to use Inspec and Habitat to protect some of our most important technical assets, and then also set up some services that help the program teams make decisions. My name is Andrew Morris, and this is my fourth ChefConf. I'm a senior site reliability engineer at the Bill and Melinda Gates Foundation, and we've been using Chef for just about a year. We are responsible for structuring and running all of the main common services that support all of our applications. So things like our public services, like our public cloud services, our main services that are in our data center, and all of the things that it takes to get stuff shipped to production. Things like CI/CD, secrets management, source code, monitoring, and even incident response when stuff breaks. Over the last 6 years, I've worked on infrastructure-y type teams with a focus on DevOps. Before I worked at the Gates Foundation, I actually worked at Alaska Airlines on the infrastructure automation team. And while I was working there, I got started with Chef and got to find some of the cool magic about how airlines work, which was fantastic. And then got really in touch with my inner compliance auditor by learning how PCI compliance works, and that was super fun. Like, if anybody has any questions about the PCI DSS, I can probably help you. Before Alaska Airlines, I worked for a casino, also on the infrastructure team, where we either built or rebuilt every single system while we were there. So from the data center, to reconfiguring all the switches, to changing all the wireless, to standing up the virtualization platform. I even got my forklift operator license while I was there, so I could run the cherry picker and hang wireless access points. Before we can hop into the technical bits of my talk, we kind of want to put some specifics around how the foundation actually functions. We have this amazing mission of all lives have equal value. And what that means is all of the things that we work on focus towards ensuring children, like more children and young people, survive and thrive. We empower the poorest, especially women and girls, to transform their lives, combat infectious diseases that particularly affect the poorest, and inspire people to take action and make change in the world. So how do we actually work? Well, a lot of the issues that we engage in and work in are extremely vast and complex, and they're deeply rooted most of the time. So none of it can be done by ourselves. Like, we can't just go and fix it by ourselves. We have to engage heavily with partners, governments, private individuals, organizations, all that type of stuff. So when we do this, we strive to have this engagement model of transparency, of candid communication, and a general spirit of trust. And what that does is our IT systems are focused around that. So most of our technology systems are built for collaboration, managing payments to our grantees and partners, and tracking the performance of the investments we make. So trust and transparency is imperative to how we collaborate. We embody these values with everything we do. As an example, our main campus was built in a way where you can see all the things that we're working on inside of our conference center and most of our offices inside of our north building. We also have an open access policy where if research is published as a result of our funding, that it should be widely distributed very quickly. 2, our grants database being accessible for all. Anyone can look up what grants we are making and who we are partnering with. Internally, we try to apply this methodology as well, even with things such as compliance in relation to how we have our infrastructure and applications configured. So this leads us to the topic of transparent compliance. Unlike a business that handles medical information or credit card data, we are not heavily regulated with strong prescriptive controls such as HIPAA or PCI. We do, however, adhere to internal security controls. We have tons of privacy policies that we need to guarantee for the people who work with us, such as GDPR, and financial system controls. This means that we still have the burden of making sure that all of our stuff is where they need to be. So running reports, gathering those reports, and configuring all those metrics, as well as presenting that to an internal or external auditor. Currently, anyone at the Gates Foundation is able to view our adherence to our technical compliance standards via the Chef Automate dashboard. This means that InfoSec and our application teams are able to check the systems that they own and care about, and then my team is able to go work on things that are more fun. Not that compliance isn't the funnest thing ever. Here's an example of what some of our users may see. This is essentially just the compliance dashboard. If you've used Automate, you're probably familiar with this tool. Hopefully, everything's blue like we have here where it says your system is compliant. In some cases, it may not be. And what people can do is they can figure out when that happened, like when it came out of compliance, what the actual issue is, and then we can give them a path to remediate that pretty easily. But how do we kind of get to that state? Like normally this is something that's very infrastructure centric, and how do we get to a point where we can kind of farm it out a little bit? So the tool that we use to check controls on settings on our servers and cloud resources is Inspec, and the reporting is done via the Chef Automate compliance dashboard. Inspec is a free and open source framework for testing and auditing your applications and infrastructure. It works by comparing the actual state to the desired state that you express in an easy to read, easy to write Inspec code. The first thing that you got to do is you got to team up with your InfoSec partners. We did this as well. Essentially, you got to get all of that Excel documentation and those Word docs where they're like, please go and check this on a server and turn that into Inspec code and profiles that are wrapped around what logic we have for our compliance. The next thing that we need to do, and we actually moved a lot of that stuff over. The next thing that we need to do is we have to figure out how we want to deploy this. We actually deployed this via like the audit cookbook. We had the Chef client on essentially all of our nodes, and this is a real quick, easy way to do it. The way that it works is you essentially go and apply this to your run list and define what profiles you want it to run on, and every single time that server goes and checks into the Chef server, it'll go and check for its compliance, which is super awesome. So about every 30 minutes is what we have ours set up for. The audit cookbook is a community cookbook, so you can get it from GitHub or the supermarket. The next thing is watch as your reporting rolls in. And this is super fun because it'll either be like, yeah, we're super awesome, or you got a ton to remediate. In our case, we have a little bit of both. We were able to start the remediation and kind of get stuff started with two ways. The first way is update our group policy, because we had some controls that were defined via group policy, and we got those tightened down, which was great. And then the rest of the changes we've been able to start rolling out via just Chef cookbooks instead of our legacy architecture. With this whole effort, we were able to decrease our environment's like security risk, like stuff is more secure. Increase our detectability of these issues, so we were able to find them sooner before they get into production. And then we also built a great relationship with our InfoSec partners, because now they are like, oh, they're essentially doing a lot of the work that we had to do for us, which is great. And I would like to give a huge thank you to Jamie Bellanosa, who's done who did most of the heavy lifting for the conversion from the Excel stuff to Inspec profiles, and we couldn't have done it without him. He also took a big hunk out of the initial remediation cycle, which was fantastic. Thank you so much, Jamie. Now to lessons learned. This is probably less of an issue inside of Automate version 2, but Chef Automate uses its own Elasticsearch cluster to hold all of its compliance and converge information. So let's say you have 1,000 nodes and you're checking hundreds of controls every 30 minutes, 24/7, and you're retaining this information forever. Your Elasticsearch database is going to get huge. So because it's embedded on the Chef server, or on the Chef Automate server, we started noticing performance issues, so we essentially were like, what's going on? And we realized it was huge, so you have two options. One is you can either move this database to an external cluster and just let it get huge and have terabytes of convergence information, or you can go and decrease the amount of information that you're retaining. This is also probably no longer an issue, but it's related to the way that Inspec goes and interrogates users for certain types of login controls for Windows machines. In this example, we're essentially running this on a domain controller, and what it does is it interrogates every single username that matches the string, and in this case, it matches all of them in your domain. So every single time that you were to go and check this control against this policy on this machine, it goes and checks 10,000 users, and it takes a while. It takes so long in some cases that it takes longer than it would have started the next one. So we start a test, and before it could finish, it starts another and another. This wasn't a dramatic issue, it was actually in this state for a couple weeks before we detected it, because we were like, wow, this domain controller is struggling, but we were able to resolve it pretty easily. The next thing is how we measure and evaluate investments results. Each of our divisions, in each of our divisions, we develop goals and strategies before allocating resources and making investments. We continually collect and share data on our progress, reflect on lessons learned, and make course corrections as needed. Essential to this process is the ongoing dialogue with our grantees and partners, which is embedded to the way that we manage our strategy lifecycle. We do this in several different tools, and we're going to kind of go over the example of one of them. What this is it's a visualization of how we kind of just manage super high-level strategy. This one is something where the program teams upload the results and articulate the portfolios in a common and intuitive way, and then provide a directional sense as to the performance and strategic importance of each of the investments. This is a pretty simple web app. It's written in Node.js. It's got 3 tiers, so you essentially have like a web layer, an API layer, and a MongoDB layer, and then we're pushing out the artifacts to a blob storage, like object. This is essentially it building, right? So what's super nice about this is it's super convenient and clean. Essentially, our team was tasked with partnering with the application team to get this project up and running. We decided to focus on eliminating runtime risk within this application and found that Habitat worked amazing for this. Habitat is open source software that creates platform-independent build artifacts, and this is essentially running through an npm build on a node box. The goal of this is to get a Docker container in the end. The first thing that happens is we have to go and build a Habitat artifact, which is like a heart file. Once that's built, we go and we export that to a Docker container, and then it's just a simple task of tagging that and uploading that to some type of container registry. Yes, we could have totally used Builder for this. We know that Builder does all of this magic. But at the time that we got this done, Builder didn't support private builds for us. And at the time, we weren't necessarily prepared to go and configure on-prem Builder. So this is essentially what we did, and this helped a ton. We were able to shrink the deployable container size of this from 2.2 gigs to just under 300 megs in this example. And the reason why that's done is because the separation of concerns between your build dependencies and your runtime dependencies, meaning that when you build your container, the only thing that you have in it is your runtime dependencies, which is awesome. From that, you get smaller size, which is fantastic, and then you get a smaller surface area of attack, which significantly increases your security. In this example, we're getting Docker containers as the output, but you can, what's super neat about this is you can essentially move this to whatever you want. So we can move this to Kubernetes, Cloud Foundry, Mesos, or we can even move it to bare metals or just a VM. It's super duper flexible. And I think we have a little bit of hand waving at the end of this, but as you can see, it's pretty quick to run through the whole build. Before, this was taking up to 20 to 25 minutes, and now it happens in the period of 4 or 5 minutes, which is super fantastic and increases our ability to deliver things to production. It finishes. The lessons learned for Habitat. One of the big lessons that we learned with Habitat was in the very beginning, we started noticing that our runs took longer and longer, and our builds got bigger and bigger. And we're like, what the heck's going on? And what we realized was we were including our results folder inside of our Git. So what happens is all those artifacts that Habitat was building, we were checking into source code. So make sure you have your results whack inside your git ignore so that you don't do that, because that's not good. In conclusion, a lot of this stuff, we're not super crazy, amazing like Alaska Airlines is right now on this, but we're just getting started with this. Don't be afraid to try these kinds of tools and roll them out to your organization. It could be easier than you think. And there are awesome communities surrounding these tools that will support you on your journey. When you have success with these new tools, you will share the knowledge with others and bring them along. The last thing is that I would like to share a really cool thing that I found at the Gates Foundation. It's a quote that hangs in our Seattle Conference Center. And I think it's really applicable to kind of the work that we do. If you want to go fast, go alone. If you want to go far, go together. And that's the end of my talk. Thank you so much. My name is Andrew Morse. Are there any questions?
Hey, so really quick, I was curious. You mentioned with like the Elasticsearch in compliance, so that's something I've run into myself. What did you opt to do? Did you opt to just not save as much data, or are you doing the external clustering?
So we don't have like a financial like hey, I have to hold this for 3 years type of regulation. So we just decrease the amount of time that we're retaining that information. And then from there, we essentially just go and say, hey, we should get this done before this rolls.
Cool. You actually asked one of my questions. That was perfect. I just came for the mic. So another question about when you started with Inspec. So did you just go full on with the CIS benchmark, level 1, level 2, and just see what you got and then remediate it? Or did you take a trimmed down custom policy and start that way?
Yeah, so initially we were like, oh yeah, let's totally apply the CIS benchmark, and then just like looked back because like I don't know if anybody's looked at that, but it's super in depth. We did do that and got the report back, and we're like, okay, what are our actual controls? And then worked with our InfoSec partners, and they were like, no, we only need these 40 or these 50 controls that are super duper duper important, and then we just pushed to getting those done. There was other things which like. The CIS benchmark is really opinionated about like things like password length and password reset history and stuff like that, and our settings were a little bit different. So we just customized the CIS benchmark. It was like customed, be advised, like this is not CIS, but here's why it's this way. Super appreciate you guys coming. Have a good one.